Hello everyone, welcome back to Chemistry 24/7. In this series, we have been exploring solution to previous year's competitive exam papers. If you are new to this channel, don't forget to subscribe and hit the bell icon for notifications. Today, we are going to tackle a problem based on several concepts such as LDA, nucleophilic acyl substitution, and molecular sieves mediated imine formation and imine tautomerism and followed by Aza-Miachel addition reaction. Let's dive right in and solve together. By looking today's problem, which is from the University of Hyderabad PhD entrance exam 2019, the question provides us with a substrate react with LDA and followed by cinnamyl chloride which produce product X. This product X react with butylamine in the presence of powdered 4 angstrom molecular sieves which produce this corresponding product Y. So here you see there are 4 options. Let's figure out to correct one together. Let's look what is the first reaction condition is. The first reaction condition is LDA. Therefore, first let's review the role of LDA. LDA is a non-nucleophilic, sterically hindered strong base that readily abstracts the proton from acidic position. We have discussed LDA before, but if you missed that video, don't worry, you can find the link in the description box below. LDA is particularly useful for the generate the enolate ions by deprotonating the less hindered site of a substrate. Let's come to our substrate. So here you see the cyclohexanone when you react with LDA, which readily produce this corresponding enolate ion. So when you come to the cyclohexanone, so here also active site, here also active site. And this molecule is a symmetrical molecule. Therefore, you can take here as well as here also, no problem. So when you use LDA, which readily abstract one of the proton, which readily produce this corresponding enolate ion. After the generation of enolate ion, which react with cinnamyl chloride. So particularly this reaction is called as nucleophilic acyl substitution reaction. Since this group is called as acyl group, so now you see how this happened. So this negative charge comes here, then followed by this electron attack this carbonyl group, then followed by this pi electron move towards to the oxygen atom, which readily produce this corresponding tetrahedral intermediate. So now you see how this tetrahedral intermediate collapse. So this negative charge comes here, then followed by kick off Cl minus to produce this corresponding product. So this is our product X. So what is the next step? The next step, the reaction of N-butyl amine with this substrate. So before that, here you closely look this substrate. There are 2 carbonyl groups are present in this particular substrate. So we know that amine is nucleophilic here. So we should find which carbonyl will react with this nucleophilic nitrogen. So when you compare these 2 carbonyl group, so this carbonyl is electron deficient when compared to this carbonyl. Since this carbonyl is involved with conjugation, okay, so therefore this carbonyl group only going to react with N-butylamine. So here you see this lone pair of electron readily attack this carbonyl carbon, then followed by this pi electron move towards to this oxygen atom, resulted that produce this corresponding tetrahedral intermediate after the loss of H plus ion. So now you see, so this intermediate quickly lost the water molecule to produce corresponding imine. So here you see how this happened. So this electron moves here, then followed by kick off OH minus at the same time, which lost the H plus together to produce this corresponding imine compound and followed by kick off water as a byproduct. Now, I should note here, so the role of molecular sieves is the drop of this water molecule. So we already know that the formation of imine reaction most of the time a reversible reaction. Therefore, if it present water molecule that will attack this imine carbon, then followed by drive the backward of this reaction to produce this corresponding carbonyl compound. In order to restrict or in order to avoid this reversible reaction, if you use powdered 4 angstrom molecular sieves that readily drop this water molecule in order to prevent the formation of this backward reaction. So now you see this imine formation takes place and closely look this substrate. So this is the imine carbon. So the near carbon is alpha carbon having ionizable proton. So in this type of scenario, this imine compound readily undergo imine-enamine tautomerism. So this one is a imine. So this one is a enamine. So this enamine we can redraw like this. So next see how this enamine react. So this enamine quickly undergo intramolecular Aza-Miachel addition reaction. So before that, we should find the electronics of this particular substrate. So now you see the oxygen will get delta positive since oxygen is a more electronegative element. So this near carbon get delta positive and this carbon will get delta negative and this carbon will get delta positive. That means that, so this carbon is electron deficient. So now you see this nitrogen is electron rich, which readily attack this electron deficient center, then followed by electron shifted here and this pi electron shifted towards this oxygen atom, resulting that produce this corresponding intermediate. So now you see nitrogen get the positive charge since nitrogen lone pair only attack this carbon. So therefore, it will quickly lose this H plus and followed by, so this negative charge comes here, then followed by pick off that H plus to produce this corresponding product Y. Based on our discussion, considering the role of LDA in deprotonation and the acyl substitution reaction and the imine formation by the aid of 4 angstrom molecular sieves and their imine-enamine tautomerism and followed by Aza-Miachel addition reactions sequence, we can deduce the correct option for this question is option D. That's it for today's problem. If you enjoyed this video, please give it a thumbs up and share it with your friends. Don't forget to subscribe and click the bell icon to stay updated with our latest videos. And leave a comment if you have any questions. And thanks for watching Chemistry 24/7. Bye bye.